Iron metabolism is under the control of several proteins that play different roles in its absorption, recycling, and loss. Dietary iron exists primarily in its poorly soluble trivalent ferric form, Fe3+. In order to be absorbed by the gut, Fe3+ needs to be reduced to its soluble divalent ferrous form, Fe2+. This process is facilitated by an enzyme called ferric reductase. Ferrous iron is taken up at the apical side of enterocytes by a divalent metal transporter called DMT1 and is transported across the brush border. To enter the circulation, iron has to be transported across the basolateral membrane by a transporter called ferroportin. Upon its release, the ferrous iron is oxidized to the ferric form and loaded onto transferrin. In the plasma, iron is bound to transferrin, and under normal circumstances, 1/3 of transferrin is saturated with iron. Transferrin receptors are present on most cells, but are most dense on the erythroid precursors. After binding to transferrin, the transferrin receptor is endocytosed, and the iron is released into acidified vacuoles. The transferrin receptor complex is then recycled to the surface. Ferritin is the cellular storage protein for iron, and it can store up to 4,500 atoms of iron within its spherical cavity. The serum level of ferritin reflects overall storage, but ferritin is also an acute phase reactant, and plasma levels can increase in inflammatory states, such as infection or malignancy. While iron is lost in sweat, shed skin cells, and sloughed intestinal mucosal cells, there is no specific mechanism of iron excretion from the human body. Thus, iron is mainly regulated at the level of intestinal absorption. The iron exporter ferroportin is upregulated by the amount of available iron and is degraded by hepcidin. Hepcidin is a small cysteine-rich catatonic peptide that is primarily produced in the liver. Hepcidin leads to degradation of ferroportin and a decrease in intestinal iron absorption. Transcription of the gene encoding hepcidin is downregulated by anemia and hypoxia. Hence, in anemia or hypoxia, iron absorption is increased. On the other hand, hepcidin is upregulated by inflammation and elevated iron levels. Hence, in inflammatory conditions, iron absorption is decreased.